Let's take a look at finding the volumes of different shapes. I have here a prism and a pyramid. And let's say they have the exact same base dimensions and the exact same height. So let's just call this 5 centimeters. We'll make that 5 centimeters. And let's make the height 6 centimeters. Same thing here. And then from the center up to the top, we have a vertical height of 6 centimeters. Well, we know that for the volume of an object, in this case we've got for the prism here, length times width times height. And the formula for the volume of our pyramid here is 1/3 length times width times height. And this leads to an interesting relationship between these two objects. So the prism that we have here and the pyramid that we have here, the pyramid will be the exact same volume as the prism, except it'll be 1/3 as much. So there's the length times width times height. There's the same length times width times height, but for the pyramid it's 1/3. So if we calculate these dimensions, 5 times 5 times 6, 5 times 5 is 25, 25 times 6 is 150 centimeters cubed, would be the volume of the prism. And here, the volume of the pyramid, 1/3 of the length times the width times the height, which is 1/3 of 150, or 50 centimeters cubed. So the pyramid, again, 1/3 of the volume of the prism if they have the exact same base and height dimensions. So there's the volume of a prism and the volume of a pyramid. Let's look at some other shapes. And there's a similar relationship between cylinders and cones. The volume for the cylinder is the base area, which is a circle, pi r squared times the height. And the formula for the volume of a cone is the base area, pi r squared times the height, but it's 1/3 of that. In other words, you could fit 3 of these cones inside that cylinder. And so, using the formulas, we can very simply determine the volume of these objects. Pi times 4 squared times the height, which would be 10 times 16, 160 pi, oops, we're using meters cubed, and 1/3 of pi times radius squared times height, which is 1/3 of 160 pi, and getting an approximation on the calculator for these, 160 times pi equals 502.65. meters cubed, and I now need to divide that by 3 because the cone is 1/3 of the cylinder, so 167.55. And remember, when we're using volume, the units are cubed because we have 3 dimensions that we are multiplying together. Here's a picture of an ice cream cone. It's even got one of my favorite flavors on it. Anyhow, let's pretend we've got to find the volume of this ice cream cone. And this is what we call a composite volume, because we actually have 2 parts to it. We have the cone part, which would look something like this. And on the top of it, we have I'm not a very good drawer of this, but we have a half of a sphere. So this is the ice cream part. Okay, which is sitting on top of our cone. So let's create some dimensions here. The ice cream cone, let's just say it has a height of, do something fairly reasonable here, 12 centimeters. And the radius of the cone might be about 4. And let's say that this also then has a radius of 4. So we've got to find the volume of the entire ice cream cone, which, as mentioned before, includes the cone part and the ice cream part, which is in the shape of a sphere, although it's just the top half of the sphere. So we're going to need the formula for the volume of a cone, and we know that's 1/3 pi r squared h. And we're going to need the formula for the volume of a sphere, which is 4/3 pi times the radius cubed. And then obviously we'll take this answer and we'll add it to this answer. When we're working on this, this will be the volume of an entire sphere, so like a ball type shape. So we're going to need to take this answer and divide it by 2 because we only have half the ball. We just sort of have the top half of a ball shape. So let's work this out. The volume of the cone would be 1/3 times pi times the radius, which is 4 squared, times the height, which we said was 12 centimeters. So let's work this out. Pi times 4 squared is 16 times 12 divided by 3 equals, always forget to 201.06. 201.06 centimeters cubed would be the volume of the cone part. The volume of the ice cream on top, 4/3 times pi times the radius of the ice cream, which would be the same as the radius of the cone. Even though it looks like it's sticking out here a bit, let's just pretend that it's the same as the actual radius of the cone. Pretend I licked it off there a bunch and evened it all out. So 4/3 times pi times 4 cubed. So 4 times pi times 4 to the power of 3 divided by 3 equals 268.08 centimeters cubed. But remember, we got to divide that by 2 because we only have half of it. So divided by 2 is 134.04. So this would be the volume of our ice cream. And then, of course, we would need to add these together. So plus 201.06. So volume total is 335.10 centimeters cubed for the volume of our ice cream cone. And just like we did in surface area, sometimes we might be told the volume and be asked to find one of the unknown parts, one of the unknown sides of the figure. So in this case, we're told the volume of this cylinder is 541 cubic feet, and we know that its radius is 9 feet. The question being, what is the height? Well, our formula for volume is pi r squared h for the volume of our cylinder. We know what the volume is, that's 541. We know what the radius is, that's 9. The question is, what is the height? 9 squared is 81, so this is 81 pi times the height. And then obviously to isolate h, we would need to divide by its coefficient, which is 81 pi. That would cancel that out, leaving us with 1h, or h equals 541 divided by 81 pi. 541 divided by bracket, because I'm dividing by two things, 81 times pi, close the bracket, it equals 2.13. And our units are in feet in this particular question. So the height of this cylinder is 2.13 feet.